Hello Math 2 students. Today is the first of 3 videos to help you review for the test. Today's video will focus on standard form. The parent function of a quadratic function is y equals x squared. The vertex of the parent function is 0, 0. The y coordinate of any point on the parabola is the x coordinate squared. So if your x coordinate is -3, your y coordinate is 9. If your x coordinate is -2, your y coordinate is 4. If your x coordinate is -1, your y coordinate is 1. When your x coordinate is 1, your y coordinate is 1. When your x coordinate is 2, your y coordinate is 4. And when your x coordinate is 3, your y coordinate is 9. And there's a graph of the parent function with those points plotted on the graph. The a value of any quadratic equation controls how wide or narrow the parabola is and the direction that it opens. When you're trying to figure out if your parabola will be wider than the parent function or narrower than the parent function, you can ignore the sign of the a value. And if your a value is a proper fraction, then your parabola will be wider than the parent function. If you ignore the sign and your a value is greater than 1, then your parabola will be narrower than the parent function. And if it happens that your a value is 1, then your parabola will be exactly the same shape as the parent function. When it comes to the direction that the parabola opens, you need to pay attention only to the sign of the a value. If the a value is negative, the parabola will open down. And if the a value is positive, the parabola will open up. Standard form of a quadratic equation is f of x equals ax squared plus bx plus c. The c value is the y-intercept. The axis of symmetry is calculated by using the equation x equals -b over 2a. The y coordinate of the vertex is calculated by using y equals ax squared plus bx plus c. And the x-intercepts can be found by factoring. Here we have the function f of x equals 2x squared plus 12x plus 10. I can tell that that function is in standard form because there are no parentheses. So when I look at this function, I can see that my a value is 2, my b value is 12, and my c value is 10. What makes this parabola look different than other parabolas is those numbers. As those numbers change, whether or not the parabola opens up or down, is wide or narrow, is shifted to the left or right, is translated up or down, all of those things change as these numbers change. So this parabola with an a of 2, a b of 12, and a c of 10 is going to look different than a parabola that has a different number in one of those positions. So now I need to know everything that I can find out about standard form. The first thing that I'm going to do is I'm going to find the axis of symmetry. To find the axis of symmetry, you have to use this formula. And I have an a value of 2 and a b value of 12. And so that'll make -12 over 4, which is -3. So my axis of symmetry is x equals -3. I'm going to go ahead and put that on the graph right now. So my axis of symmetry is going to be a line that looks like that. One side of my parabola will be to the right of that line, and a mirror image will be to the left of that line. The next thing I'm going to do is find the y-coordinate of my vertex. And to find the y-coordinate of my vertex, I need to use this formula right here. And I'm going to replace my a with my a, my b with my b, my c with my c, and my x's with -3. Now I have to go in the correct order of operations when I do these calculations. So the first thing in the correct order of operations is the math problems inside parentheses. Well, I don't have math problems inside these parentheses, so I keep going. The next thing I'm going to do is the exponents. So negative 3 to the second power is 9. After doing the exponents, the next thing we need to do is multiplication. So 2 times 9 is 18, and 3 times 12 is negative 36. Now if I take 18 and negative 36, that makes negative 18. And negative 18 plus 10 is negative 8. So my vertex for this problem is at negative 3 and negative 8. So if I go 3 to the left and down 8, that will be my vertex right there. The next thing I know about standard form is that my C value always tells what the y-intercept will be. And so my C value is positive 10, so my y-intercept will be right here at positive 10. Now I have 2 points on my graph, the vertex and the y-intercept. In order to graph this, I'm going to need to plot more points on my graph. So I'm going to want to make a table. And on my table, my vertex will fill the very middle position. And from negative 3, 1 to the right is negative 2. And from negative 2, 1 to the right is negative 1. From negative 3, 1 to the left is negative 4. And from negative 4, 1 to the left is negative 5. So now I need to calculate how to find these values. But I know that whatever value I get for negative 4, negative 2 will be the same. And whatever value I get for negative 5, negative 1 will be the same. So now I just need to do those calculations. So I'm going to start by putting the negative 1 into my original function to find the y value. So that will be y equals 2 times negative 1 squared plus 12 times negative 1 plus 10. And again, I must go in the correct order of operations, so there's no math problems in the parentheses, but I do have to do the exponents. Negative 1 to the second power is 1. And then I have to do the multiplication. So 2 times 1 is 2, and 12 times negative 1 is negative 12 plus 10. And we have 2 and negative 12 is negative 10 plus 10. So our y-coordinate is 0. So when x is 1, y is 0. That means that when x is negative 5, y is also 0. Now I need to do the same exact process, but I'm going to use negative 2 as my x-coordinate. So I have y equals 2 times negative 2 squared plus 12 times negative 2 plus 10. I have to do the exponents first, so I have y equals 2 times 4 plus 12 times negative 2 plus 10. So I have y equals 8 minus 24 plus 10. So that's y equals 8 minus 24 is negative 16 plus 10. And negative 16 plus 10 is negative 6. So when x is negative 2, y is negative 6. And when x is negative 4, y is negative 6. Now if I plot all of those points, I will have enough information to make the graph. So over 0, or over 5 to the left and up 0. Over 4 to the left and down 6. Over 2 to the left and down 6. And negative 1 and 0. And so now if I connect those points, I will have my parabola. I can see that there's an extra point that I can add on. Here, 1, 2, 3 spaces away from the axis of symmetry, there's a point at 10. So 1, 2, 3 spaces away, there's going to be another point at 10. And here's what my parabola will look like. So my vertex is at -3, comma, -8. My y-intercept is at 10. My x-intercepts are at -1 and -5. The only other thing that you need to realize about standard form is if you take an equation in standard form and you factor it, you can find the x-intercepts. So just to show you how that works, I'm going to take my original function, I'm going to factor it, and my x-intercepts are going to come out to -1 and -5. So what I want to do is I want to find the x values when the y value is 0. So I'll have 0 equals 2x squared plus 12x plus 10. And when I look at my three values, my a, my b, and my c, I can see that they're all even. So I'm going to take out a greatest common factor of 2. So my remaining factors, if I divide every term by 2, I'll have 1x squared plus 6x plus 5. So now I need to find two numbers that multiply to 5 but add up to 6. That will be 5 and 1. Since all of my signs are positive, my signs are going to be positive when I put it into intercept form. And the x value that will make this turn into 0 is -5. And the x value that will make this turn into 0 is -1. So my x-intercepts are -5 and -1, which matches exactly what I have on my graph.